Welcome to Space Gas's Steel Member Design video series. In the next few videos, we will show you how to design or check the steel members in your model against one of the various international steel design codes available in Space Gas. The model you see on the screen has all of its structural and load data previously defined, and the model has been analyzed. A steel member design requires some extra input data that can be defined in a datasheet or graphically. Let's use the graphical input method by first selecting the right-hand rafter and then choosing Steel Member Design Input Form. Starting at the top of the form, the steel member number must be unique for each steel member. The description is optional, but helps you to keep track of things and makes the design reports more readable. The member list contains a list of the analysis members that make up the steel member. In this case, our rafter is made from just one analysis member, member 16. You can choose between normal or high-strength steel. The actual steel strength is taken from the steel sections library and varies slightly for each member size. The destabilizing effect of gravity loads applied to the top flange of a member can be taken into account with the load height position setting. Because our rafter is loaded through purlins attached to the top flange, we will choose top flange loading. Effective lengths and flange restraints can be defined in terms of actual lengths or as ratios of the total steel member length by setting the units to actual or ratio. In this case, let's choose actual. By setting the scan code, we can tell Space Gas which types of members to choose from when doing a steel member design. If you are not sure what to use, click the Select button and then choose the desired library and the required section type. You can choose more than one section type by holding down the Control key while making your selection. In this case, we will use the Australian library. However, note that many other international libraries are also available. Note that the scan code only applies to design mode and not to checking mode. The compression effective length for buckling about a member's major axis can be calculated from a buckling analysis or defined manually. In this case, we will obtain it from a buckling analysis. If the steel member is braced in position at both ends, Space Gas limits its compression effective length to no longer than its actual length. This is done regardless of whether the effective length was obtained from a buckling analysis or was defined manually. For buckling about the major axis, our rafter is free to sway, and so we must leave it unbraced. Similarly, the compression effective length for buckling about the member's minor axis must also be defined. We will again obtain our effective length from a buckling analysis, and because our rafter is likely to be braced in the out-of-plane direction at the ridge and at the knee, we will say that it is braced in position at both ends. Bending effective lengths can be calculated automatically based on the flange restraints below, or can be defined manually for positive and negative bending. For non-cantilever members, it is usual to have them calculated automatically. Seismic checks can be carried out for steel members. To activate these checks for a particular steel member, you must specify its seismic classification. For a non-seismic member classification, seismic checks are not carried out. Defining the flange restraints correctly is important because they affect the performance of the steel member significantly. You can position them anywhere along either or both flanges, and you can choose between full, partial, lateral, and rotational restraint types. Continuous lateral restraints can also be defined. For this rafter, we have 4 intermediate purlins spaced 1.2 meters apart along the top flange, and we can define them in the top flange restraint positions field. Their positions could be defined as 1.2, 2.4, 3.6, 4.8. However, it is much easier to simply enter them as 4 at 1.2. We can then move across to the restraint types field and define what type of restraint the 4 intermediate purlins provide. You can see that 2 Fs already exist there. They correspond to the restraints at the ends of the member on the top flange and signify that they are full restraints. We need to insert the type of our intermediate restraints between the 2 Fs. If we assume that our purlins are providing lateral restraint to the top flange, we can insert a single L. It will apply to all 4 intermediate restraints. The bottom flange of our rafter has no intermediate restraints, and so we can just leave the bottom flange restraint fields as they are. Note that the default full restraints at the ends may not always be appropriate for your situation, and you may need to change them. If you are not sure what restraint codes to use, click the Restraint Type Help button to get a list of what is available. Further information on flange restraints is available in the main Space Gas Help system. Eccentric effects can be enabled or disabled for members that have eccentric end connections, such as single-angle sections connected through one leg or channels connected just through the web. For bolted tension members, in which the area of steel removed by the bolt holes affects the tensile capacity of the member, you can specify the number and diameter of the bolts. The hole diameter is assumed to be bigger than the bolt by 2 mm if you're using metric units, or 1/8 of an inch if you're using imperial units. For angle sections, you must specify if they are single or double angles. This setting only applies to design mode and not to checking mode. Connections are assumed to be concentric, however you can also choose between various types of other end connections. This affects the eccentric end moments and shear lag. Finally, the design can be based on minimum weight or minimum depth. Now that the design data for this member has been defined, we can click OK to exit the form and then show the flange restraints visually by clicking the View Steel Member Flange Restraints button on the side toolbar. In the next video, we will define the design data for the other members in the model.